Hey guys, Space Marine 658 here, and today I am going to be talking to you about state trees. They are a relatively new addition to Unreal Engine, and I thought I would kind of go over them because there's some really cool features in them, especially now that there's been some changes made since they were originally released. Now these are subject to change because of course they're still listed as experimental, but they are really cool, and there's a lot of cool things you can do with them. So let's go ahead and just get started off. You're going to want to actually enable them inside of your plugins. So you go ahead and type in state tree. There are two here that you're going to want to select. So there's gameplay state tree and then state tree. Go ahead and check mark both of those. You have to restart your editor, and once you do, you'll be back here. All right, so once you've done that, you will be able to go here inside of your AI board and hit state tree. Now I'm going to create a new blank one so I can kind of show you what it looks like starting off, and then we'll kind of walk through mine. And so what you'll want to do is up here at the top there's state tree component, and that's what you'll want to select. And then go ahead and give it a name. For now, since this is just going to be deleted, I'm just going to call it ST placeholder. All right. So when you first load it up, you'll see here you've got a very blank template. You've got something called a context actor over here, and then you've got the context actor class. So basically what a context actor is it basically gives the state tree information about what actor may be running this tree. You can be very specific, or you could do a parent class. So you could even leave it as just a plain actor. The problem is the more generic you leave this, the less information your state tree has about the actor actually running the state tree. So for me, I'm going to go and select my base ship AI since that is the parent class that I have. And then from within here, now let's say I want to actually, use this actor context somewhere. There's a few different ways you can use that. I'll show that later on once we actually walk through some examples of states and tasks. But let's go ahead and look at the rest of the UI here. So we have three things: parameters, evaluators, and global tasks. So what parameters are basically things that you can include inside of your state tree that can give it, a little bit of information for whatever reason. So this is an example. Let's go here and let's actually reference our fleet manager. So we have a fleet manager object here, and we can give it a name. We'll say, let's call it manager. And then we could select one directly from in world, or there are ways to set this based inside of your actual. Okay, you actually can't set direct actors. Oh, that's interesting. I've never actually tried to set a direct actor. So yeah, let's go ahead and clear this out. What you can do instead then is inside of your individual actor, you can actually set this as a target. So let's actually show that in a slightly different way. So I have my main actor here with its own state tree component, and I've just got a blank vector parameter here that I've set to 000. I don't really use the parameters much because you can't pull or push information through them. But they are great for setting any kind of defaults or anything that you want for your state tree to have. So let's talk a little bit about how to get a state tree on your actor. So that's pretty simple. You just add the component here. So you just hit add, type in state tree, and that will add it here to your actor. And then from there, you select the actual state tree from this little drop down here. Going back to the state tree. And so that is your basic way of getting your. Let me actually open up the one we were working in. So that is a parameter that you might be able to have. So let's go ahead and remove this. We've also got a thing called evaluators and then global tasks. So what evaluators are is you can create evaluators within your project. And so for example, here I have an evaluator called player tracker. The way you do that is inside of here, you just right click, go to blueprint class, and then type in evaluator, and you'll see you have a state tree evaluator blueprint base. If you go ahead and click that, you can create an evaluator. And basically all an evaluator is you've got three options. You've got tree start, tree stop, and event tick. So basically this is something that runs separate from your actual tree itself, and it just gathers information needed to make evaluations. So this will grab, states that your AI has, or for example, here I'm tracking the current player's location. So whatever kind of information that you need your tree to have, this is one way to do that. Now, when you're creating these evaluators, something you're going to want to know is that to get these to show up here, to not just have them in your evaluator, you need what's known as categories to be listed correctly. So as you can see here, I have this category listed as output, and for this one, I have it listed as input. Now, to actually have these show up that way, you have to have that exact name. If you type it in differently, they actually won't show up here in this section. But as you can see, since this one's listed as input and these are listed as output, it's got an in and an out here. What this lets you do is actually reference things within that evaluator task to actually do things based off of whatever you're passing in or pulling out. So as an example here, my evaluator takes in an AI context ref. So that's a reference to the current AI that it is running on. And it actually, because I've got it listed as that actor, it's then using that information to go in here, and it's saying, hey, off of that AI context ref that you're passing in, give me the orders, give me the current actor location, give me the current waypoint, and give me if their current movement is completed. And so with that, all of that information gets passed back to the tree, and now I can access this in other sections. So think of this as a way to pull in data to your tree. Now let's go ahead and talk about global tasks. Now global tasks are similar to evaluators in that they're something running on the tree itself and not any individual state. But they're different in that tasks are more specifically very specific. Let me go ahead and, like, for example, so we got a wait task here. So with a global task, these are things that you want running all the time that maybe, is not specific to any one state. For example, you might have your AI check the time of day, so that your AI, wants to know if it is a certain time of day, I'm going to know to do these things. But it's not something that necessarily your AI character might have anything on them to track that. You have like a level blueprint that has a time of day tracker, right? And so this task can just hit that level blueprint and go, what time of day is it? And if you reach a certain point, then you could either fire off a state, or you could trigger something else like switching your trees. So if you want to go from daytime tree to a nighttime tree or something like that, as a great example in Minecraft, spiders during the day are very calm, peaceful, and won't really attack you unless you attack them. But at night, they do come after you. This is a very, very good example where you might use that. So you have a global task checking the time of day. If it is during the day, you run one tree. If it's during the night, you switch trees. Now, when you're switching trees, this global task will have to be on both trees, but it would allow you to switch between the two. Let's go ahead and remove that there. And as an example here, now that we're kind of talking about tasks in general, inside of tasks, you have things called functions. And let's actually show, to create a task, if you want to follow along, you do the same thing as you do with the evaluators, except you type in task. And what you'll have here is a state tree task blueprint base. Go ahead and click that and give it a name depending on what task it's doing. So within each task, you're going to have 4 functions. You've got enter state, exit state, tick, and completed. And what these do is basically every time your tree's tick runs, whatever state you're on, or if it's a global task, it just runs by default, and it tries to fire one of these tasks. And let's say, for example, we've got this wait task there. A wait task does an event tick. So what that does is it checks the delta time, minuses it from the current duration, which is what we set here. Whenever we added it, there was an option to set current duration, and that's because we have that over here. So as an example, let's go ahead and put in our wait task. So we have this duration that we can set, or we can base it off of something. So if we want to set it off of some other value, we can do that as well. But once we've selected whatever our duration is, this will actually just minus it to count that time down. And then as you can see here with tasks, you don't have to have that category. Now there are times when you may still want that category, because you can use that category to clarify some things. For example, we've got these current durations and durations. Now, if you had a very complex task, you may want to have a few different things, or if you wanted to bring anything in, for example, the ship here, it just helps to clarify the different sections of the task. But the event interstate fires anytime you enter the actual state of this task. So for a global task, this is just on tree start. And then exit state fires anytime you leave that state. So once your different states transition fires and it moves from one state to another, that is when the exit state will fire. But yeah, so for example here, I'm just checking the duration. Once this duration is completed, I call a succeed task. So what this does is inside of here, each task can either succeed, fail, complete, or tick. And so let's actually go take a look at that. Oh, and then we also have an event. So there's an event that can be called to trigger transition. So there are ways to trigger these to force them to change from within your actual character itself. But yeah, so we have on state completed, on state succeeded, on state failed, on tick, and on event. Now, for anything that is sort of a variable that can change, most of the time I find that doing a conditional on tick is usually the easiest way. So for example, here I've got this waypoint travel. Basically, my ships will just go from point to point to point. Basically, I just check if they are within a certain distance of that point, so less than or equal to the evaluators player, the evaluators pull in current location of the AI and then the current waypoint for that AI, its location. And I just basically go, is the current location less than or equal to the target location distance of 1500 Unreal units? If that is the case, then I also want to look at, is the current waypoint completed, which is something I set inside of my AI when I come to a full stop. If both of those are completed, then this succeeds. So what this will do is this will say, hey, this was successful, all conditions were met, and so it moves on to the next state. Now, it doesn't necessarily have to be the next state. You can have it do next state, but you can also have it say that the tree itself succeeded or the tree failed. So if you want to have trees within trees, you could have them nested in such a way that if this is like a routine, so if you're doing GOAP, so goal-oriented, what's the second half? Basically goal-oriented AI. This could be basically a daily task that your AI is doing. You could have like 10 of these. And let's say this is the first one called. You can have it succeed or fail, and then based on that, choose a different tree. That is one of the ways you could do that by transitioning here. Or you can go to a different state. So you've got the root state and then all the different states. The cool thing with this is that you can actually go to any state within the tree. You aren't required to go up to the parent states. And so you can go to anywhere in between. So that's kind of how a task transitions. Now, within this, when we're kind of talking about tasks in general, tasks are meant to be sort of leafed out like this because they are doing separate things. And the idea is your transitions should move your state you should move from one state to another with transitions. And what this allows you to do is sort of guide your AI. So for example, here for my patrol, This is a state that's actually known as a group. So it's not actually doing anything itself. It's just looking for interconditions. If those interconditions are met, it then runs. And so it says, hey, I'm traveling from waypoint to waypoint. And then I'm waiting once I receive it or once I get to waypoint, and then I go and find the next waypoint. And then this repeats. Now, the only time this exits is if the orders change. So one thing I haven't talked about yet is interconditions. Interconditions are how you get from your root into any of the child states. Now, the way I have mine set up is at the top, I have a group, which there are 4 different kinds. We'll talk about that here in a sec. There are 4 different types of states and roots, and the top level states to me are always groups, because those are sort of a general idea of what the AI should be doing. And then within those, you have the actual states that are doing the actions. And so what I do is my root doesn't have any interconditions, because it is literally just grouping all of together this set of actions. In theory, as the AI gets more complex, you could give it other things. So for example, let's say I have all this, but to make sure that the AI doesn't do any of these, when it reaches a certain state, let's say a morale threshold, my AI gets so afraid that it breaches that morale threshold. I could have 2 roots here, where one's root and one is like what do they call it? Flee. Is a flee state, and that could have its own tasks under it. So it would be like, back away from combat, run away, or something to that effect. And I could make it so that if morale is above a certain percentage, exit the root state and go actually to this other state. And the cool thing is that you can do that in a way that you can exit from any point, but without interrupting your AI in a weird, strange way. Because a lot of times interrupts cause AI to act very strange, and it can give you a lot of headaches and make things confusing. With these, since these are transitions, it makes things a lot more coherent, and things make a lot more sense when you're planning your AI's actions. So to just give kind of an example of that, I have here, all of these different states are based off of the orders that my AI receives. So I've got a enum compare at the top of every one of these states. That is actually, basically it checks their orders. So if they have one of these orders, they will enter the state that matches that order. Now, this also depends on my selection behavior up here, which we'll also talk about when we talk about the type. But for now, just all you need to know is that it tries it from top to bottom. And so it checks the first one and goes, hey, is this my enum state? No. Then I move to the next one. Is this my enum state? Yes. Then it enters, and this is going to repeat until that state changes, because I've actually set it here. So if my enum is no longer equal to the enum that got me into here, then I'm going to exit and go to the full stop state. Now, I don't go to the all stop state, because this I want to reserve for when the order is to all stop, because there may be times when I want my AI to actually give the order to all stop versus when I'm just changing from one state to another. Now, in theory, you could separate those out. You could have another state down here that is a one that you send them to rather than the actual order itself. But I like having it here, because this kind of gives me the ability to directly order the AI to go to the state. But so what'll happen is, so let's say I've got them in patrol and I change the enum so that they're actually going to form up. What'll happen is it'll hit this waypoint travel, and it'll go, oh, I've received new orders, and it's going to go straight to here. This is going to call that function on my player. So I call this task. And to kind of give an example of what tasks kind of look like, let's go ahead and look at the formation task. So for me, I use this to call timers on my AI. There's a lot of different ways you could handle this. You could do AI move tos. You could do, depending on what you're actually doing, there's a lot of different things you could do. Now, I'm doing a space game, so for me, I find it easier to just, since I have a reference to the ship by having the input here, I just call the function on that actual character, and that just starts a simple timer that then does my actions that I want. Now with that, since we're going to want to jump from here to here, how do we actually get there? Well, when I change the enum and this actually fires that transition, it's going to jump down here to full stop. It's going to call this task. This task is going to fire. And since this itself has transition state, it's going to keep firing this until it actually reaches that next state. This will succeed because this itself is checking this trigger on the state completed. So once it reaches a full stop and it's realized that it has come to a complete stop, it triggers that the state is completed, and then it moves down to the wait. I've just set it to wait 5 seconds, and this actually goes all the way back up to the root, so that way it can actually figure out what its next orders are. So since I was at patrol, I moved down here. My state, or my enum, is now no longer patrol. I've actually moved it to form up. And so what happens is this continues to fire and does all the things it needs to do until it actually exits the state, goes up to the root, and then it's going to go through, do that check again. It's going to go, oh, I'm not loitering, I'm not patrolling. Oh, I am forming up. And then it's going to come in here and complete all these tasks. So that's kind of an overview of state trees. Let's kind of go into a little bit, just touch on, how these actually work when it comes to your AI. So I've added my state tree here, the base ship, state tree. I set it to start automatically as false by default because I want to do all my setup first. Add it to the viewport, give it a 5-second delay so that when the game starts, it doesn't immediately start running the tree. But once that's done, I'm going to start the logic and I'm going to start doing my avoidance collision. So this is something that could be a global task. Currently I have it set as a separate thing because I'm still tweaking it a lot, making a lot of changes, and in the future I can always move it into a global task. But essentially this just checks for any collisions. If it finds them, it tries to move. And so with this, it's all pretty straightforward. There's not actually a whole lot in here. Each state is given its own task. So as an example here, I've got, the patrol task. In here, I've got the wait task, I've got the update waypoint. So I created a task for each one of these. Some of these will overlap. For example, these different weights all use the same weight task, but I could have different timing for them. If I wanted to, I could set one to 5 seconds, set one to 10 seconds. This is just entirely up to me. And so with that, let's go ahead and actually talk about the different types and selection behaviors of states. So at your most basic level, you've got 4 states. You got your state, which is the actual state containing tasks and children states. Then you've got groups, which are states that only really are ever used to contain other child states. Now they still can have transitions and inner conditions. But the idea is these are things that are just holding other states together. So for example, my loiter here, this is also a group because it is not actually doing anything on this state. I am just using it as an inner condition check. Then we have what is known as linked states. So basically this is a state that is linked to another state in a tree. So basically what this lets you do is, let's say you've got, so this all full stop, right? Let's say I want to link this to Rome so that whenever Rome is firing, full stop should be firing too. That is to allow you to basically have 2 states be firing at the same time, even if they are on different parts of the tree. Now I haven't played too much with linked type states myself. I just don't find I have much need for them. But if that's something I would like to see, let me know in the future. But otherwise, let's carry on. We also have subtrees. So subtrees are actual a way to link to a different tree. So let me actually go ahead and add a sibling state here. So here's how you add your child states and sibling states. Let's add a sibling state and we'll just call it linked tree. So we change this to be a subtree. So then within this, you can add, parameters like you can with the normal tree. You can add inner conditions, task transitions. What this basically does is basically marks to you here at the overview, like as you can easily see that this is a very different kind of state. And this is basically just saying, hey, this state goes to another tree. So that way you can just know that at a glance, this is what this does. If we looked at linked as well, you can kind of see how this would be linked, and you can list a linked subtree here. Although it doesn't seem to want to let me. But yeah, this is how you link a different subtree. And so that is pretty much state trees. There are a lot of different ways to use them and different ways to access them. Let's talk about, let's actually just remove this placeholder. We're actually going to talk about specifically when talking about state trees is, all right, sorry about that. But yeah, so one thing we're going to want to talk about last is the actual selection behavior. This is pretty straightforward. Essentially is you can have different selection behaviors for different states. So the cool thing with these is that this means that you can kind of alter how your actual states interact. So as an example here, I have, there's 4 different types. So there's none, which means that this state itself cannot be directly selected, which is sort of like basically saying that this state cannot be chosen as a mode to be entered. Then you have the try enter, which means that the state can be, when it's considered selection, it is selected even if it has child states. So it means that like you're marking the root, loiter, and roam all at the same time. Then you have the try selected children order. What this does is this actually tries to do it in sort of top down. So it'll go loiter, can I enter here? Patrol, can I enter here? Farm up, can I enter here? And then you have try follow transition. So first this will actually try to trigger the transition. So basically it goes, can I transition from here to here? If so, then just skip that and go to the next one. But if it goes no, then okay, I can enter here. And then it goes down that. So if you have like a really long task list, but you actually want to kind of go, skip anything that it can already skip. So for example, if you had a task that was go grab a weapon, instead of having the AI going and grabbing the weapon from the start, it will actually check the transition first. It'll go, oh, can I actually transition just to the next state already by default? I can. Boom. I'm going to skip this state then and go to that one and actually just try and continue from there. I personally prefer to do it in order because this makes more sense to me logically. I'm thinking, this is the order, and if I want them to transition, I can just have those transition states ready to trigger immediately, basically on tick. But yeah. So that is the majority of state trees. They are still really new, so things can change. If that does happen, I'll probably make another video. But otherwise, they are really handy to have. Let me actually just go ahead and kind of show you. Let me go ahead and let's see here. Let's just make sure we got a decent formation. Yeah, and then let's give them the order to. They're set to loiter. We'll do a patrol. We'll send these ships up to patrol. And then, oh, I forgot. I was doing some bug testing earlier to help someone out. So let's remove this breakpoint. And then let's go ahead and hit play. 11. All right. And you can see there, after about 5 seconds, the AIs have all triggered. And they will start making their way towards whatever randomly selected waypoint they have chosen. Now, of course, they're going to collide when they get there because the patrol is more designed to be, smaller groups, like 1 or 2 ships. With big number of ships like this, there's pretty high odds that they will collide. Now, I do have some logic around the collisions, that way to hopefully prevent them from all colliding together. So you can see there, once they got there, they called the all stop. That is just to make sure that, I've got it set to patrol, so that way it'll actually swap between the different orders there. So they went from patrol to loiter. Now in the final version, of course, they'll have different, ways to decide what tasks they're going to be running using orders coming from the fleet manager. But for now, I wanted to test the different features out. But yeah, so that is pretty much state trees in a nutshell. If anyone has any questions, definitely let me know. But otherwise, good luck and good hunting.